This is your 12.3, and that's infinite limits. It says here that a vacuum pump removes 25% of air from a steel jar with each stroke. The jar starts with 1 liter of air in it. In other words, after each pump, we will have 25% of the amount gone, all 75% left over. So after the first pump, we'll be left with 0.75. After the second pump, we will have 25% of 0.75, which is 0.5625, and I'm using my calculator to get these values. After 25% again, I will have at the third one, 0.421875. After the 10 one, I will have 0.05631, and so on. Well, the end one, I will have 0.75. Instead of showing you what I will get, I want you to get your calculator, and on your calculator, put 0.5675 or 0.75 first, and raise it to the power of 2. 0.75 raised to the power of 2 is what we got after the second pump. In other words, if you do also keep raising it to the power of 2, actually I was supposed to start again and do 0.75, this time raised to the power of 3, to see if I get the third one, and yes indeed I get the third one. So my equation seems to be 0.75 raised to the power of n. So because here is to the power of 1, 0.75 to the power of 2, 0.75 to the power of 3, that's 5 to the power of 3, 0.75 to the power of 4, and if you keep going, at the end you have 0.75 to the power of n. And here of course is 0.75 times 0.75 to the power of n minus 1. That's again the recursive formula. The question here says, will the amount of air in the jar ever actually reach 0? The answer will be no. Why? Because you're just taking 0.75, you still have 0.75 of the amount left over, meaning you will never take the whole thing. So as n approaches infinity, s of n will also approach 0. Now, I look at the limit as something related to my horizontal asymptote. You should remember that high over low, we used to say slang to go. Low over high, y equal to 0, and when they're the same, you play the coefficient game. We will apply the same rule here. For example, here is low over high, so I will say is equal to 0. But another way of thinking about it is x is going to infinity, so x gets bigger and bigger and bigger, and when you divide 1 by a big number, you get approximately 0. Now, the limit of 1 over x as x approaches infinity means that what are the value of 1 over x approaching as x approaches infinity? The limit can be found by substituting large values of x. I prefer that you just use your high over low, low over high, and when they're the same. The only key is that high over low, when it's high over low, you will say infinity. Low over high, it can be infinity, positive or negative. So it depends on the sign. You will know when it's positive and when it's negative. Low over high, we will get 0, and when they're the same, and it will be the coefficient game. So on this specific one, I have the same 3 to the power 3n and n. The coefficient game will therefore be 3 over 1, which is 3. Now the second one, again, we have the same power, so the coefficient game will here be 1 over 1, which is 1. On the fourth one, this time it's high over low. When it's high over low, n being squared, that means no matter what value, whether it's positive or negative, we get a positive infinity. So infinity is your answer. I'm gonna move to the next one. Here I have 1 minus 2n over 5n. Once again, they're the same, so it's negative 2 over 5, your answer. 4n squared over n cubed, that's low over high. Low over high, I say it was equal to 0. Yes, it's this simple. I can show you other ways, but it makes it harder. Number 7 is slightly different. The first thing I will do is I will cover this portion, the portion I'm about to highlight. I will cover this portion because it has nothing to do with regular polynomials. So once I cover that portion, I will just try to figure out what the answer will be without the cover portion. The answer normally, n4 and n4, it will be the same, it will be 1/2, but that's not it. I will ask myself, as n approaches infinity, what will be -1 to the power of n goes to? Well, -1 to the power of n will be -1. If it's even, it gave me a 1, but if it's odd, it will give me a -1. So my answer seems to bounce between positive and negative. Since it's bouncing between the positive and the negative, I put plus and minus. The limit should give you an exact value, a single value. Bouncing in between positive and negative allows me to write does not exist. It only means that the limit does not exist because it keeps going between plus and minus. If you graph this, it will look kind of like a sine or the cosine function bouncing up and down. Let's look at the next one to see if that limit exists. The first thing is, just as we did on the previous one, I will go ahead and cover this portion for now and just figure out what I get. By covering that portion, I will have n over n squared minus 1. Well, n over n squared is low over high, meaning it's equal to 0. At this point, whether -1 to the power of n is 1 or -1, the value remains 0. So 0 is my answer, because 0 times 1 and 0 times -1 is still 0. Let's look at 9 now. On 9, it says limit. I'm applying the same concept. First step is to cover. So what I will do is I will cover this portion, not this portion, that's what I'm working on. And once you cover this portion, you get the coefficient, play the coefficient game because they are the same, and that will be 5 over 2. Unfortunately, 5 over 2 will not stay the same because even will give me positive, odd will give me negative. So it's actually plus and minus 5 over 2. So my final answer is does not exist. Instead of writing does not exist, I will put does not exist from now on. All right, let's look at 10. On problem number 10, this time I have -1 on top. Well, since there's no variable, I take it as 1 over n, and of course I cover this portion. 1 over n, once again, is low over high. Low over high is equal to 0. Once the outside gives you 0, I don't even need to bother looking at that -1 because 0 times anything is 0. Let's look at the last two. The last two might be slightly confusing, but keep in mind, for high over low, low over high, or when they're the same, you focus only on the factor that has the highest power. Now, the factor with the highest power on top here is 4 to the power of n. The factor with the highest power on the bottom is n squared, but inside the radical, it's just as if it was n. So at this point, I have the same, so my answer is 4 over 1, which is equal to 4. Let's repeat it now on problem number 12. The highest factor on top, as n goes to infinity, this is infinity by the way, the higher factor on top, the highest power, will be 2n. On the bottom would be 3n squared. So it's actually square root of 3n. I'm finding the square root of 3, and the square root of n squared is n. Now if I play the coefficient game, I get 2 over square root of 3. To be fancy, as you know, I like my answer fancy, it will be 2 square root of 3 over 3. Now, will it be positive or negative? Obviously, it will be positive. Now, I'm looking here, it seems like it's negative infinity. Now, if I make it go to negative infinity, that will change both ends and make it go to negative infinity. So your final answer is this, being negative. Again, I changed the sign just because I noticed that this one was negative infinity, not infinity. Because it's negative infinity, that makes everything, the ends, negative as well. So this answer is also negative.